In this video, we're going to talk about how to write the equation of a parabola given the vertex and a point. So remember, we talked about how to identify the key characteristics of a parabola based on its equation in vertex form. The first thing we can identify is whether it's a vertical or a horizontal parabola. If the term being squared is x, that means it's a vertical parabola. If the term being squared is a y term, then that means it's going to be a horizontal parabola. We can also determine the direction of opening and the vertex, and for vertical parabolas, we can determine whether the vertex is a maximum or a minimum. We can also use the equation to figure out the axis of symmetry. So let's start off with this problem. So let's write the equation of the quadratic function that represents a parabola that curves up, has a vertex at 2, 1, and passes through the point 4, 2 in vertex form. So if it curves up, that means that's going to be a vertical parabola, right? So we already know the equation is going to be y equals a times x minus h squared plus k. Okay, so it says we have a vertex at 2, 1. So the vertex at 2, 1 means that's the value of h and k. And then it tells us that we have a point at 4, 2. Well, the point of 4, 2, it just gives me an x and y value. So I can actually take all of these values and plug them into my equation. So I have 2 equals a, which I don't have any information for a, except I know a is going to be positive because it curves up. And then I have x, so I have 4 minus h, which is 2, squared, and then I have plus k, which is plus 1. So I have 2 equals a times 4 minus 2 is 2, so I have 2 squared plus 1. So now I'm going to turn this into 2 equals a times 2 squared is going to be 4a plus 1. And then now I can solve for a by now subtracting 1 from both sides. When I subtract 1 from both sides, I get 1 equals 4a, and I can now solve for a by dividing both sides by 4. So when I divide both sides by 4, I get 1 over 4 equals a. So if I plug this back into that original equation, I have y equals 1 over 4 times x minus h, so minus 2 squared, plus k, which is 1. So that's the equation of this parabola in vertex form. Let's go ahead and try writing the equation of the parabola that's represented in this graph, and let's write it in vertex form and then convert to standard form. So let's look at this parabola. It opens sideways. It opens to the right, so we're going to need the form of the equation x equals a times y minus k squared plus h. Once again, we have the vertex. The vertex is at negative 1, 4, so that's going to be the h and k values. We have 1, 2, which is a point, so that's going to give me my x and y values. So let's plug this all in. Plugging this all in gives us the equation 1 equals a times 2 minus 4 squared plus negative 1. So we have 1 equals a times 2 minus 4 is negative 2, so we have negative 2 squared minus 1. Negative 2 squared is 4, so we have 1 equals 4a minus 1. So now let's solve this equation for a. So we start off by adding 1 to both sides, and when we add 1 to both sides, we end up with 2 equals 4a. So now we can go ahead and solve for a by dividing both sides by 4. So we have 2 over 4, which reduces to 1/2, so we have 1/2 equals a. So let's go ahead now and plug this all back into that original equation. So we have x equals 1/2 times y minus 4 squared minus 1. That's the equation of this parabola in vertex form. So now you can go ahead and pause the video and try doing this example on your own. So here you can see the parabola opens up, so it's going to be vertical. So we use y equals a times x minus h squared plus k. We have the vertex, which gives us the values of h and k, and we also have a point, so that gives us an x and y value to work with. So we plug this all into vertex form, and that gives us 1 equals a times 0 minus negative 3, which becomes plus squared minus 2. So we have 1 equals 9a minus 2, and when we solve for a, we get a equals 1/3. So in vertex form, the equation will be y equals 1/3 x plus 3 squared minus 2. So remember, given the coordinates of the vertex and a point on the parabola, you can write the equation of the quadratic function it represents in vertex form.